Okay, this is our third video about stormwater, and we're now going to actually show you how to calculate the amount of stormwater you're dealing with before you develop and after you develop. A lot of this you're going to notice is very similar to the previous videos, so I may go over slides quickly. You should pause and take notes as you need. So where does the stormwater go? We already saw this on those pictures. Absorbed, running off, or we detain it in a pond or a storage. All of these items affect how much runoff we're going to have. And we've already talked about it. When we develop, we increase runoff and we decrease absorption. And guessed it, codes and regulations tell us what we need to do. We need to protect the environment, protect the property because we don't want the water running off, and reduce impact on our storm drains. We don't want flooding downstream. Things that are important that we're going to use in our formulas. Rainfall intensity. Is it a light shower? Is it a heavy shower? 1 inch of rain over a week is almost no problem because it's going to be absorbed. 1 inch of rain in 1 hour is going to cause a lot of runoff. Soil type. We're actually going to talk in depth about soils on our next section, but what kind of soil you have makes a difference on how quickly the water will be absorbed. Slope should make sense. If we're talking about a steep slope, the water's going to run off versus if it's very flat. Soil conditions and vegetation. Is it lawn? Is it natural plants? Take a second, read through these, take notes if you need. So this is the formula we're going to be using. Take a minute, write this down, and write down what each of these means. So the first one is based on what kind of storm we have. So this is like a 100-year storm. CF would be a 1.25. If it's a 1-year storm, it would be a 1. Now when I say a 100-year storm, that's how they classify different types of storms and weather. A 100-year storm says that on average, there's just a 1% chance that we're going to have this storm in any given year. Or on average, we'd say over 100 years, we'll just have this storm once. It doesn't always work out that way due to statistics. Again, I mentioned intensity already. It has to do with how much water we get and how quickly. We start with the design storm. Code tells us what kind of storm we need to design our drainage system for. And in any problem or any real life situations, you'd be told what kind of storm to design for. Often it's just code that's telling us this information. And this is what I just said a second ago. So we have rainfall intensity maps that you can find and you use. And we also have tables. This happens to be the table for Nashville, Tennessee, and this is the one we're going to be using. And notice here it says the duration, and here it says the years of occurrence. So if I wanted to know a 100-year storm for 1 hour, I'd look at 100-year, and I'd look for 1 hour. I could also look up a 100-year storm that lasts 12 hours long, and I could see that number. Or a 100-year storm that all came down in just 5 minutes. That would be this number. And I'm looking at the number at the top, not the range at the bottom. They also have intensity graphs where you would read them by going to a 100-year storm, or this is the intensity, and this is the duration of the storm, and the color denotes the intensity. So here's an example problem we're going to work through. We have a 3-acre farm in Nashville, Tennessee, and we're going to put in a parking lot there. We're going to calculate post-development and pre-development. Pre-development means before we do it. Post-development is after. Here's our formula. A is the area of the acre and properties. Do remember you have to use the area in all of these as in acres. Intensity we get from here. We're talking about a 25-year storm in 1 hour. So here's our I value we're going to plug in. C is our runoff coefficient, and we originally had farmlands. You're going to read this from the table. And we find that this gives us 0.5 to 0.3, and our problem said to use the average of these numbers. Add them up, divide by 2. Sometimes it says to use the most conservative number, which would be the biggest number. Sometimes it says to use the average. It was a 10-year storm, so we see 10-year storm is right here. That's our CF. So we plug all these numbers in here. We plug them all in, multiply. This is cubic feet per second. That's the flow from our storm, 1.5 cubic feet per second. Now after we've made the development, we need to calculate up each different area. Parking, change the 30,000 feet with our conversion factor over to acres. Farmland, that we left it as farmland. And then we have intensity, same as before. Runoff coefficient for farmland, we look it up on the table. This is the same number we had from before. And the asphalt, we're going to use this one. Now when you're doing a section that has different kind of areas, we have to use this formula. If I only have 2, I use this one where I multiply C times A, here C times A, plus the other C times A. If I had more terms, I would keep going plus C times A, plus C times A. On bottom, I just add up the total area we're talking about. And remember, please excuse my dear Aunt Sally, multiply on top before adding. Do the entire top before you divide by the bottom. Here's your C number for this one. Plug those in here to get your post-development analysis. I'm not going to explain this alternative method, but you're free to look through and see how that works. Then to find the difference, well, the difference just means subtract. Post minus pre, big minus small, and we see that the difference is an extra 1.5 cubic feet per second. In fact, we've doubled the amount of cubic feet of runoff with our development. Again, these are the same ways we saw in the previous video. Remember our lead points that we had back when we talked about residential? Here's some of those. Read over them. And that's the end of this. I've given you a packet to use. It has the tables you're going to need, as well as a step-by-step worked out problem that you can use as an example as you work through your activity.